we're going to do another AP free response. This is 2005 Form B, BC free response 1, which is a parametric question. As with all question 1s in the last decade and a half, this is a calculator permitted and sometimes required question. All right, so we're given that an object is moving along a curve in the xy plane, and it has position x of t, comma, y of t, for t is greater than 0. We are given that dx dt equals 2t minus 3t squared. We are given that dy dt is the natural log of the quantity 1 plus the quantity t minus 4 and the quantity to the fourth, and close the entire natural log. So again, the first thing I'm going to suggest you do, and you don't have to do this, but I think it's a good idea, since it's a calculator question and you know you're going to have to do stuff with the calculator, I would suggest that you put this guy in as your x1t in parametric mode, and I would suggest that you put this guy in as your y1t in parametric mode. As we've discussed several times, make sure that you're putting parametric equations on sort of the same derivative tier together, right? So if you're going to put dx dt as your x1t, make sure that you don't put just regular y. Make sure that you put dy dt as your y1t. So I'm going to go ahead and enter this in my calculator because I think it's going to turn out to be useful. And then once it's in our calculator, we can go ahead and start mathing. I'm going to do a quick double check that it's in the calculator right. Cool. So it should look something like this when you put it in the calculator, right, as your x1 and your y1. All right, so at time t equals 0, the object has position negative 13, comma 5. At time t equals 2, the object is at point P with x-coordinate 3. Cool. Find the acceleration vector at time t equals 2, and find the speed at time t equals 2. So they're not asking you to find the acceleration all the time. They're only asking you to find the acceleration at 2. So for part A, acceleration at 2 should be x double prime of 2, comma, y double prime of 2, right? Which I can find using my calculator because I've already typed some stuff in, right? So I'm going to find this by doing n derive, which is math 8, right, of x1t with respect to t at 2, and then I'm going to do the same thing here, but I'm going to do n derive of my y1t with respect to t at 2, and I'm going to get an answer for both of those that is a nice happy decimal. So, you don't have to do it this way, but it's definitely the easiest option. So I'm going to go ahead and show you what I mean by that, right? So I'm going to hit math, right? And I'm going to hit 8. I want vars over to y vars and pick parametric, x1t, comma, with respect to t at 2, and I hit enter. And I get a 0, which doesn't feel super satisfying. I'm going to be honest, it makes you feel like you just shouldn't have bothered to use a calculator, but it is what it is. And then I'm going to do the same thing for y, but instead of reinventing the wheel and retyping it, I'm going to hit second enter, and I'm going to go over to where my x1t was, and I'm just going to type over with a y1t. So I'm going to go to vars, over to y vars, down to parametric, and I'm going to pick y1t and hit enter, and that feels a little more satisfying because I got a decimal, so I get negative 1.882, right? So that's my acceleration vector at 2. Keep in mind that this question had 2 prompts, and a lot of us sometimes forget to do the other one. So I've got my a of 2, right? Great. My second prompt was, what is the speed at 2? So again, it's up to you how much you want to use the calculator to do this and how much you just want to do it by hand. My speed should be the square root of x prime of 2 quantity squared plus y prime of 2 quantity squared. And I've shown you this trick in other videos. My suggestion is that you can find this x prime of 2 very easily by graphing your parametric function that you've already put in, and then hitting trace and 2. And that'll give me the x and y coordinate. It turns out the x coordinate is 12 and the y coordinate is 2.83 and some stuff, right? But the cool trick about this is not that it gives me the x and y coordinate that I can write down. The cool trick about this is that if I quit out of this right now and type alpha x using the x button at the bottom of my calculator, not the one that I would normally use because this is a t right now, if I hit enter, there's the 12 I was expecting, and if I hit alpha y and hit enter, there's that 2.83 stuff I was expecting. So it's easy enough to type in the square root of alpha x squared, sorry, it's a rough angle to see this, plus alpha y squared, close the parentheses, and boom, there's my speed at the point I was requested to find. So, oh, and ignore my dt, because sometimes my brain just does stupid things. No dt, you're not integrating. 12.329, or if you are rounding, it would be a 330 at the end. Again, sorry about that dt in a previous part of this problem. All right, cool. So that's part A. Double check that you do both prompts because they're both pretty accessible prompts, and it's a real bummer to miss easy AP points because you just missed out on doing the second prompt in a really simple part A. Part B, find the y coordinate of P. Okay, so let's go back and figure out what the heck P was because they mentioned it and then we promptly forgot. Okay, so we know, all right, so part B, right, we know 2 points. We know that the position at t equals 0, right? We know that at t equals 0, the position is negative 13 comma 5. Great, right? What that essentially tells us is that x of 0 is negative 13 and y of 0 is a 5. Great. But they also tell us that there's this other time t equals 2, and at that time we're at point P, which has coordinates 3 comma blank. So what that tells us is x of 2 is a 3, but y of 2 is a big fat question mark, right? So this is what they're asking you to find in part B. What is the y coordinate of part of point P? So this is that same first fundamental theorem of calculus that we've seen before, right? So we've seen the first fundamental theorem of calculus in almost every parametric problem that we've done, right? When we do this, we usually see this with f's. We usually see it as the integral from a to b of f prime of x dx gives us f of b minus f of a. And when you see this, this is a situation where you're able to integrate this either on a calculator or by a given graph, and you know one of these two quantities and you want to find the other. The way that we're seeing it here is we're seeing it with that dy dt, right? Remember that dy dt is the same as y prime of t. So if I were to integrate y prime of t with respect to t, from let's say 0 to 2, and the reason I pick 0 and 2 are because I know y of 0 and I want y of 2, I would get y of 2, sorry, there's an equal sign there, minus y of 0. Well, the reason that's relevant is y of 2 is the thing that I was asked to find, that's the thing I want, and the y of 0 is a thing that I know, and as I mentioned up here, this is a thing that I can make my calculator do, right? I can make my calculator integrate. So I'm going to add that y of 0 over, and I'm essentially going to get that my y of 2 should be y of 0, which is a quantity I know, it's a 5, plus this integral from 0 to 2 of the natural log of 1 plus t minus 4 quantity squared with respect to t. And then I'm going to let my calculator do all the heavy lifting. So when I go to put this in my calculator, I already know this is a 5, right, plus, and then what I'm going to type in my calculator is function integrate of my y1t with respect to t from 0 to 2, and when I do that, I'm going to get a value out that is approximately a 13.671, and that is my y of 2. All right, cool. Let's talk about part C. All right, part C. Write an equation for the line tangent to the curve at point P. Cool. Oh, so that's relevant there, which I should have probably mentioned a second ago. It is relevant that I probably cared enough to store that point that I had, although I don't necessarily need it, but we'll go back to that in a sec. All right, so here's what I know about point P. I know that point P, right, point P is 3, comma, a 13.671, right? And this was my answer. This was my answer to part B, right? Okay, so in part C, they ask me for a tangent line. Anytime for the rest of math, forever and ever and ever, that you're asked to find the equation of a line, number 1, you need a slope, number 2, you need a point, and number 3, you should write your answer in point slope. There's virtually no reason to simplify that answer and try and clean it up because you just risk making a simple mistake. So I already have the point, right? Check, point 3, comma, all of this mess that I got from part B. Cool. I need the slope. So if I can find my slope, right, my slope, which I'm going to call mt, right, it should be dy dx evaluated when t is 2, which essentially just means that I'm evaluating my dx dt at 2 and my dy dt at 2, right? So dy dt evaluated at 2 on top of my dx dt evaluated at 2. Evaluated at 2. That was a hot mess. Take it back. All right, t equals 2. Now, I'm going to make the argument that you can use that same trick that I've used before, right? You can use that same trick. Now, you could just straight up plug a 2 in here, and I have no problem with that. If you want to do it, it's great, it's fine. If you want to just plug in a 2 here and plug in a 2 here, if you plug a 2 into this expression, you're going to get a 12 out, right? You're going to get 24 minus 12, you get a 12. If you plug a 2 into this expression, you're going to end up getting a natural log of 17, which is fine. So one option is to say, you know what, forget it, my slope is a natural log of 17 all over a 12. That's not wrong, fine. If you then type that in your calculator, you're going to get a 0.236, which is totally fine. The other way you can do it is you can use that trace trick that I've told you to use before, right? So the other way that you can do it is you can go to your graph, right, and you can hit trace and 2, and you'll get an x and y coordinate. In fact, you'll get exactly the x and y coordinate that I got here, which is natural log of 17 and a 12. And then if you quit out of that, they are stored as your x and y, so you could do alpha y divided by alpha x. And there you go, your 2.26, blah, 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 or 2.3, sorry, can't speak, 0.236. So you could either use the trick where you graph it, and then you hit trace and hit t equals 2, and then you do the y coordinate on top of the x, and you get that. Or you could type it in by hand, or you could do it like this. I don't care. Any of those options that you pick, excuse me, for any of those options that you pick, your answer is going to be y minus the y value equals your slope, 0.236, x minus the x value. There is no incentive in the whole world to clean that up. You should leave the answer that way, because if you don't, you risk making a simple mistake, multiplying wrong, adding wrong, whatever. There's no reason to change it. All right, cool. Part D, after I get a drink of water. Cool. Part D. On part D, we are asked for what value of t, if any, is the object at rest. So the trick is that at rest means two things in parametric, right? To be truly at rest, right? At rest in parametric means that you are at rest both horizontally and vertically. So what it means is that both dx dt and dy dt equals 0. Both of them. That's the important information. Now, one of these you can find really easily by just doing some factoring, and that's fine. The other one you could probably actually solve pretty easily, or you could use a calculator. It's up to you. All right, so let's find these values. So you could put them in your calculator in second calc 0. However, the caveat to that, and I've already explained this a couple times, is that your calculator doesn't do second calc 0 in parametric mode. So if you wanted to make your calculator find these zeros, you would have to switch to function mode, put this guy in as y1 and use 12x minus 3x squared in second calc 0, and then put this guy in as, let's say, y2, and put natural log of the quantity 1 plus, in parentheses, x minus 4, close the parentheses to the fourth, close the whole thing, and then second calc 0. That's fine. You can do that, but at least in the x of t case, it's really not worth it. It's way easier to say, hey, when does dx dt equal 0? Well, it's when 0 equals 12t minus 3t squared, and that absolutely factors. So I'm going to take out a GCF of a 3t, and I'm going to be left with 4 minus t. So either t equals 0 or t equals 4. Great, I have two possible candidates. Honestly, you could do one of two things, right? You could solve for when this equals 0. There's nothing wrong with that. It's absolutely fine. Or you could be kind of a lazy bum and realize that the only two possible candidates that could even be answers are 0 and 4, so you could plug in 0 and 4 and see what happens. If 0 makes this expression 0, then the particle is at rest at 0 because both dx dt and dy dt are 0. If 4 makes this thing 0, then it's at rest at 4. Again, it's only at rest if both expressions are 0. So one cheat to this, if you're like, hey, I'm just not about doing the math on this, is you do the math on the easy one that factors, and then you just test the numbers. Now, it turns out that it's actually not awful to solve dy dt equals 0, so I'm going to solve it, but you don't have to solve it. There are ways around this if you don't want to. You could have just plugged in to see what happens. So if I want to solve this, I would solve it by exponentiating. So I get 1 equals 1 plus the quantity t minus 4 to the fourth. I subtract the 1 over, and I get 0 equals a t minus 4 to the fourth, meaning that 0 has to be a t minus 4. Oh, look, t equals 4. So the only time that this side is 0 is at 4. This guy's 0 at both 0 and 4, but to be at rest, both of them must be 0, so the answer is only t equals 4. Again, if you hate this idea of solving this, if your brain just had a mental shutdown as soon as I exponentiated, you could have found the two easy answers and then just checked them to see which one makes your dy dt 0, if either.